Hi y'all. So we are on chapter 2 now, and chapter 2 is 2 categorical variables. So all of chapter 2 is 2 variable data, but with section A, it's just categorical data. There's 3 AP videos. You don't need to watch these videos unless you feel like you really need to, okay? So I started on this, and then I realized that I was off screen. So what I started to say here is that we have 2 variable data. So we have variables that'll be on your x-axis and your y-axis. And our x-axis, when we think of this in function notation, we call these the independent variables. And in stats, we call it explanatory. It's an explanatory variable. Now, our y variable in function notation has always been our dependent variable. So if you think about function notation, f of x, we plug in x, and we get some output f of x. So this is the same as saying we get some y. So with an input-output table, when we plug in x, we get a y. But in stats, we plug in an explanatory variable, and we get a response. So depending on what variable we plug, or what value we plug in, our dependent, or what we get out of that, the outcome is going to be the response. So if we look at some examples here, just to try to put it in perspective, we want to identify explanatory and response variables for these following relationships if we can, okay? So the weight in carats and the price in dollars for a sample of diamonds. So if you think about this, we have the carat or the weight of a diamond, and that's going to be our explanatory variable. And depending on how big that carat is, right, we're going to have a price, and the price is going to be our response. It's our output. All right. So with this next example, it says heart rate and whether or not they are an active member of the gym. So here, if they're an active member of the gym, that's going to be our explanatory. It's going to probably tell us what the heart rate is. That's the response. If you're not going to the gym, your heart rate is probably going to be a lot higher than if you're fit. Okay? Last one here. Hair color and eye color for a sample of students. So hair color and eye color for a sample of students. So in this case, sample of students is our explanatory variable. And if you think about this, if you just look around the classroom, so you have a sample of students, and based on those students, you're going to get a hair color or an eye color. So both of these are our response variable. Now, this case, because this is categorical, it kind of is it's a lot harder to look at it than it is with the first two, because the first two we can have a quantitative output, and that quantitative output makes this concept of f of x a little easier to understand. Okay? So now what's going to happen is we're going to take this data, our 2 categorical variables, and we call, whenever we have 2 variables, we call it bivariate data. So sometimes you might see 2 variable data, or you can just see bivariate. And so that's going to tell you that you have 2 data points. And we can look at the data in a 2-way table. So we've looked at 1-way tables before, but this is a 2-way table. So what it's saying here is that the raw data is given to us in this 2-way table, and then we can come up with specific solutions based on what it's asking, okay? So if we look at this data, it's a couple of different things. We've got Democratic and Republican Party, and then we have different regions of the country. So this is one set of data, and this is the other set of data. And so it all goes together in this table. So within this, we have 3 different types of frequencies that we can pull out of this. All right, so the first one would be a joint frequency. And if we have a joint frequency, it says that the frequency in a cell and the total number of daily values. Well, here's the total. The total's down here on the bottom, so here's my total, and it goes this direction. And then this is also my total, and it goes in this direction. Now, very often, the total columns aren't going to be present on your data, and you're going to have to go in, and you're going to have to actually calculate what the total is by just adding across the top. So if we have joint relative frequencies, it's telling you that you have a value that's in a cell and the total number of data points. So here we have a single cell value over the total number of values. So if we have marginal relative frequency, Well, margin, to me, this is the easiest one, because if it's marginal, think about this. Where's the margin in a book? It's on the outside, or it's on the bottom. You set your margins when you print a paper. So when you have anything that's marginal, it means you're using the data that's on the outside of your table relative to the total number of data points. So both joint and marginal relative frequencies, we're dealing with this total value of 50. Then we have conditional relative frequencies, and this is kind of wordy, but basically it's saying the ratio of a joint frequency to the ratio of a marginal frequency. And if you do that, what ends up happening is you're not dealing with a total overall, you're dealing with what's ever in your column. So we would either deal with all of the numbers in one column or all of the numbers in a row. So conditional is either going to be column or row-based. And then what's also super important as we look at two categorical data is this point right here. In fact, I'm going to highlight this, association. So just because the data shows us something, does this really mean that this is going to be a predictor of the answer, of the results that we're looking for? So you have to ask yourself, is there a change in the data? And so if there is, then we know there's an association, okay? So let's practice this. Let's practice this right here. So we have this data, and the first thing that it's going to ask us, if we flip this over, is we want the joint relative frequency of, the percent of states that are in the Midwest and voted Democratic. So joint relative, this tells me that I have to have a total. And I know right now, without even looking back at my table, that my total of all of those points is 50. So if I look back over here, and I want to know the states in the Midwest, so that's this column, that voted Democratic. So it's this one value right here of 4. So my joint relative frequency is 4 divided by 50. And if we plug this in, we get 0.08. Now, this doesn't ask us or tell us, oh, it does. It says percent. So because this is a percent, we have 8%. Now, let me write something on here. So we can also, this specifically calls out a percent, but we can also see proportion. And if we see this as a proportion, then we're going to list this number of 0.08. Okay? So make sure you look and see, does it ask you for a percent or a proportion? Okay, marginal. So we know marginal is going to be on the outside, and we also know that it's going to deal with a total. So we know this before we even plug anything in. So it says the percent of states that are in the South. Well, we know we have a total of 50. So we go back to our table, and we look at the total that are in the South. That's here. It's in the margin, being on the outside. So I would have 16 divided by 50, and when I plug that in, I get 0.32. Convert this to a percent, and I have 32%. Okay, last one, conditional relative frequency. So this means I'm going to look at either a column or I'm going to look at a row. And it says, of the states that voted Democrat. So let's deal with our denominator first. Of the states that voted Democrat. So if I look back over here, of the states that voted Democrat, so this is Democrat right here. So I'm going to use this value of 25. Okay, so that's going to be my denominator. What percent are from the West? So I'll go back over here. From the West is just 8. So what you see is that for conditional, everything is in this one row. Okay, I could have asked the question, out of the West, how many of them voted Democratic? And I would still use this number 8, but now out of the West, I'm going to use my value of 13, and now it's all in one column. Okay, so if I go over here, I said that number was 8. So 8 divided by 25 also gives me 0.32, which is 32%. Okay, so here's an example problem, and it talks about environmental club membership, I'm going to give you a little cheat sheet table. And I want you to just go ahead and write it over here. And this might help you if it asks you specifically for, hold on, let me just make my table really quick. So I want to look like this. If it asks you specifically for joint, marginal, or conditional, this kind of helps put this all in perspective. So what happens here is we have variable 1 that'll be across the top usually, and then variable 2 along this side, okay? And what we have is that as we sum these up, this would be the sum of my rows, right? Sum of my rows, and these would be the sum of my columns, and this would be my total value right here, okay? So what I'm going to do is I'm going to take these data points that I have here and create a table that just makes it easier. Let me grab a different color pen. So if I put some values in here, like let's just say that this is A, and this value right here is B, and my total value right here is C, then what I know is that if I have joint relative frequency, my percentage here is going to be my cell value divided by the total. If I have something that's marginal, my marginal percentage is going to be on the outside, so it would be B over the total. And if I have my conditional, this is within a row or within a column. So this one is going to be A divided by B. So that's just a little cheat sheet of what this data looks like, okay? All right, so let's go down here, and I'm actually going to pause the video, and I want you to try to do this on your own based on what we did up above, okay? And then come back and I'll talk through answers. Okay, so let's go through this together. I'll talk a little bit about it. So this first one, percent of people in the sample that are in the environmental club that are members. So I want to know of all the people in the sample, environmental club members. So if I look at this, the environmental club membership is this column right here. So I have 305 over the total. And so this would be, it's not asking it, but it's a marginal relative frequency. Okay, now if you rounded this to 20%, that's fine. You can round that to 20%. Let's look at this next one, proportion. People in the sample who have never used a snowmobile. So people in the sample who have never used a snowmobile, that's out here. This is also marginal because it's the total people. So this is another one that's marginal. Okay, so for this next one, it says, what is the distribution of environmental club membership? So we have two things. We have the people who are not in the environmental club and the people who are in the environmental club. So if we look at this data up here, the people who are not would be 1221 divided by the total, and then 305 divided by the total for the people who are. And we've already done this one. We answered this one in question number 1. Okay, so we have two answers. 80% are not in the club and 20% are in the club. Okay, so look at the next one. It says the percentage of people in the sample are environmental club members and own snowmobiles. So if we look at this now, it's still environmental club membership, but we're not looking in the margins anymore. We have something specific. They're in the club and they own a snowmobile. So we're using this value of 16. So now we have something that is joint. It's not in the margins anymore. The next one, proportion of the people that are not in the environmental club and have never used snowmobiles. So same thing, are not in the environmental club and have never used snowmobiles. So we're picking one value out, so this is also joint. Okay, number 6, percentage of the environmental club members in the sample are snowmobile owners. Now, this one is a little different. So it says what percentage of, so here's my word of, very key, of the environmental club members. So we have to go up here and we have to say, all right, these are in the environmental club. So here my denominator is now 305. It's not the total sample set anymore. It's just those that are in the environmental club. And how many of those are snowmobile owners? Well, it would be 16. So 16 out of 305. So this is an example of a conditional. And I'm going to write this a little different. We don't need to write this way right now, but this is how we're going to do chapter 4. So this percentage of environmental clubs. So what we're saying here is we want to know a proportion, and this proportion is how many are owners given they are club members. So let me read this again. What percentage of environmental club members in the sample are snowmobile owners? So we're looking at the probability that they are snowmobile owners given they are club members. Okay, let's look at this last one. So this last one says, what proportion of snowmobile renters in the sample are not environmental club members? So again, proportion of snowmobile renters. So I'm going to go up here and I'm going to look at the total number of renters. Total number of renters is 574. And how many of them are not in the club? 497. So 497, so this 0.866, and then, and that's a proportion. And so let's write this in probability notation just for practice. So what we want to know is how many of them are not members given that they are renters. Okay, so this is going to be super important when we get to a later chapter. So it's good to kind of start introducing this a little bit now. Okay, all right, so if we look at this data, so this is all pulling our categorical data from a table. But now we're going to look at it from a graph standpoint. And I'm going to change these colors because I don't like how it looks. So yours might look a little bit different, but that's okay. So we have 3 ways that we can look at this. So the first one is a side-by-side bar graph. So we did bar graphs with one categorical variable data, and now we have these side-by-side bar graphs. So if we look at our axis here, it says environmental club membership. These are the people that are not in the club, and these are the people that are in the club. And then it tells us how many of them own, rent, or have never been on a snowmobile. So it's super easy to compare the data. This says percent, but this can also be a count or a frequency. It doesn't have to be a percent, okay? Now we have something called a segmented bar graph, and that's what this is. This one is our segmented bar graph. And what we see here is that the total on this segmented bar graph is going to add up to 100. And so this one does need to be a percent. And what happens is we've taken these 3 graphs that we have, these 3 bars that we have over here, and we stack them up, okay? So it's just another pictorial view of what this looks like, but it's in percentages. More often, this is in counts. And so we can look at this and we can say, okay, do the majority of the environmental club members, so that would be yes, they're a member, have they never been on a snowmobile? And we would see this bar right here would be at about 70%, and so we could say yes, the majority of the environmental club members have never been on a snowmobile. So this is just another way to look at the data so that it sums to 100%. Okay, now we could also do this in a pie chart because it's categorical. It sums to 100%. What's nice about this is it's easy to compare 2 variables. When we do a pie chart, we have 1, but now we're comparing 2 different variables. So that's why we would use this segmented bar graph. Now, the new one, and the one that we're going to talk about right now, are mosaic plots, and that's what this is. This is a mosaic down here. Now, what a mosaic plot does is it's also based on a 100% scale. So we have this percentage here. And if we did proportion, it would just be that this would be 1, right? So the proportion here would be 1, but more often you're going to see it as percentage. So let me go back and ask this question again. So we said the majority of the people in the environmental club, I'm back here on the segmented bar graph, majority of the people in the environmental club are members and have never been on a snowmobile, and we would say yes. However, when we look at a mosaic graph, what it does is it accounts for your population, or I'm going to change this. I'm going to say sample size. It accounts for our sample size. So if we go back to our table, back here, we have 1,200 people that are not members of the environmental club, and we have 305 members of the environmental club. Well, this, we have 4 times as many members. And so if we look at the amount of people that have never been on a snowmobile, when we looked at just a segmented bar graph, right, we say, well, the majority of the people are part of the environmental club and have never been on a snowmobile. When we look at the data here, we get the values of how many people that really is. So if we're looking at our percentages, right, our sample size, we have 1,200 people that are not members of the environmental club, and we have 305 people that are members of the club. So what the mosaic does is it accounts for the population or your sample size. So now when we look at this, we can say all of these people are not members of the environmental club and have never been on a snowmobile. So what this does is it allows you to take data here that is a little bit skewed because we don't know the sample size and get a more realistic picture to what our amounts are in each group. Now we still don't have the counts, but we have the percentages, and if we look at this, we know that this is 4 times the size of our members that are in the environmental club. So this amount is 4 times what this amount is when we're talking about sample sizes. Okay, and you're going to be doing some data, some evaluations where you're looking at mosaics and drawing conclusions based on the width of these graphs, right? So we know that this is about, 36 or 37%, but we know that it's 4 times as large, the sample size is 4 times as large as it is for those members that are in the environmental club. Okay, all right, let's keep going here. So here's an example. Another example where we're going to pull data off of a chart, and then we're also going to look at the data in a mosaic, okay? And I'm going to do the same thing. I want you to go ahead and pause this and work through the questions that we have here, and then the mosaic, and then I'll come back and talk through it, okay? All right, here are my results. So let's see if there's anything really I want to say here. So proportion of adult passengers. So when you see this of adult passengers, I know this whole thing is adult passengers, so that's always going to be my total, right? So same thing here, passenger of adult. And with this one, those that survived, that would be out here. So this would be marginal. And then this says how many were in third class. Well, how many in third class is in my table. So this is going to be a joint. Now, hopefully you tried this, but this is what this would look like. Proportion of survivors that were third-class passengers. So, third-class passengers, given that they survived, all right? So I would have 151 over 442, and then, and that is also joint. That's in a row, 151 over 442. And then the percentage that survived, given they were third-class passengers. So this is joint, but this is joint in a column, right? So if I look at this, this is joint in the column, right? So I would say that's also joint. Okay, so if we look down here, we have this mosaic. And here's my mosaic. And basically this little box here just says it's much easier to compare the percentage of passengers in first, second, and third class. So what does the mosaic graph reveal about the relationship between the class of travel and survival status for adult passengers? And then is there an association between survival rate and class of service? So when I look at this graph, I see a lot of red. And the majority of the red is right here. And so what I would say, what does it show? It shows that our third-class passengers were most likely to die in the sinking of the Titanic. And so is there an association between survival rate and class of service? Well, there is, right? So we see this. So yes, there's an association. And we want to use the word association. That's stats specific, so we're not going to say correlation. So in math class, we would talk about a correlation, correlation constants, or there's a correlation between, but in stats, we say there's an association. So we see here, just from a percentage standpoint, the majority of the people in first class survived, and we look at the quantity of people who perished in the sinking, and it came from third class, okay? All right, let's move on to something else now. So if I have a perfect example of a multiple choice AP free response question. So fourth grade children were asked what emotion they associate with the color red. The responses for emotion and gender of the children were summarized in this two-way table. So we have males, this male, female, that's my first data point, and then across the top here I have the different pain, happiness, so-and-so, right? So what it's saying is what proportion of the males associate the color red with love? So we're dealing with just males. So the males are going to be this row. So for me to know what the row is, I have to have the total. And this is the part that I've been giving you, and this time we're going to add it up. So if I have 35 plus 27 plus 12 plus 38, I have a total of 112 males. And it says how many of them associate red with love. Well, that value is 38. So if I have 38 divided by 112, so that would give me 0.3393. 0.3393. Now this, it doesn't say this anywhere, but because we're dealing with one row here, and when I have total, it's just the total of the guys, not the total of everybody. If I added everybody up, I would have a grand total down here. So my value is 3393, which is number C. And this would be conditional. This is a conditional probability because it's just in one row. We're just comparing guys. Okay? So let's look that here. So here's another question. There's a stereotype that everybody in LA has a cell phone. Researchers decided to collect data to determine if LA people were indeed more likely to own cell phones than other Californians. The two-way table and the two different bar graphs were created. Okay? So I have the tabular data right here, and then I have a segmented bar graph that says LA here on the bottom and owns and doesn't own, and then I have owns or doesn't own, and then I'm looking at just LA or not in LA. Okay, so let's look at our questions. The first question says, which plot, so which of these two graphs, make it easier to answer the question, are LA people more likely to own a cell phone than Californians? Well, if I look at this, I would say, and I'm going to count this as plot 1, and I'm going to count this as plot 2. And what I would say is that plot 1 is a better representation. It's asking which plot makes it easier to answer the question. So I'd say plot 1 is easier, and my why, my because here, is that the x-axis makes it easy to see LA versus non-LA. Now, I can still see LA and non-LA in plot 2. I can also see like percentages. I can pull my percentages off of this because I can see its relative frequency, but this just makes it super easy, right? So what we see here is that LA people are more likely to own a cell phone than other Californians. So people in LA were at almost 80% versus people who are not in LA. The second question, what does the other segmented bar graph tell you? So what I would say here is that graph 2 would answer the question, if you own a cell phone, do you live in LA? So if you own a cell phone, you're in LA or you're not in LA. who does not own a cell phone in LA or not in LA. And so what you would see is that if you own a cell phone in California, you are more likely to live in LA. So I think that this question here is super important because what we're doing is we're looking at our x-axis and how we have these split out. Okay, I think that's it. Hold on. Yep, that's it. All right.